everyone, this is Shannon at Thermaltake, and today we're going to take a look at how we build some of our primary components for our new DIY liquid cooling, specifically the Pacific Radiator series. Now we're going to take you through some steps through our manufacturing facility to show you how we turn components like this into a finished product like this. Now let's take a look at what we've got going on over here. And the first step is the large laser cutting machine. This is the machine that takes the flat stock material and creates all the core components to make our radiators. So let's take a look at how this huge machine cuts out all the precision materials needed to make these devices. Now with the laser cutter, we got all the in-tank pieces, the top pieces, the side plates all cut out. However, the core material requires something a lot more intricate, and that's where this comes in. This is actually the fin material that allows the thermal transfer, transferring the heat from the water to the air. So you can see behind me where it all gets cut out all by hand. Okay, now that we've showed you how all the individual components are made, we're actually going to show you everything that goes into making a 240mm Thermaltake Pacific Series radiator. So here's the finished product. Here's everything it takes to build one, starting with the 13 individual large and small tubes, your 2 end tanks, obviously your top one with the main 4 ports, and your other relief port at the bottom. You have 13 different fin array packages, your 2 side plates, which are Thermaltake marked, and of course your two top head or end plates. All of this comes together to make this. So now let's take a look at one being built by hand, which all Thermaltake radiators are hand built. Let's take a look at one being built right now. Okay, first you can see the hydraulic jig which he has set up. He just put the first side tank in, the side tank plate, and he's starting to feed in the fins and the separate tubes. These are going to go between the fins and allow the dissipation from the water to the air. Now you can see every one of these is hand stacked. So this basically, as it goes along, you can see each one is being put in, and that allows perfect alignment every single radiator that's built. So now we're going to go ahead and fast forward through this, show the build assembly, and then we'll pick this back up at the end of when everything's put together. Now as you can see here, this one is finalized, it's assembled. The in-tank part, bottom parts are actually put together. You can see the fins are pressed on. They're all pressed in place, and the bottom tank plate is going. Now let's go take a look at the area where we apply the flux and move on to the next step. The next step is adding flux to the radiator. This allows impurities to be kept out of the solder or the welds, or in this case the brazing, and allows full strength of all of the connected areas. So let's go ahead and send it through so that we can go on to the next process. Okay, now you'll notice now I'm wearing these kind of silly gloves here. That's because after the flux machine, it actually has to go through an oven to dry the flux so that we don't have any adverse effects, or even worse, it runs off. We want it to all stay where it's supposed to be so that the welding and the brazing can be done properly. Now, this is for my own protection because obviously it's very hot. So as you can see, we now have our radiator out of here. So now we need to go get the end tanks put on so that we can actually go through the brazing process. Okay, now you can see that both end tanks, you have your bottom end tank and your top end tank, are actually placed in the form ready to go. And so basically, you're going to use hydraulic pressure to push these into place and be ready for the brazing. Okay, and now here we have it. End tanks are assembled. Now we've got to run it through the next one. Now I'm going to show you this big beastly brazing machine they have over here. So let's go check it out. Now you all have an oven in your house, right? Imagine having an oven 80 meters long. That's what we have here. This is what we use to bake or braise our radiators together. By brazing, we're actually taking, instead of doing an intermediate solder or welding material, we're actually allowing the materials to melt to each other, which allows optimal thermal transfer from the tubes to the actual fins itself, which basically allows much better heat evacuation. So this is a process that takes about an hour and a half from end to end for this to travel through all the heat and then cooling process. So let's send it through and see it come out the other end so we can take you on to the drilling and everything else to finalize what it takes to make a Thermaltake radiator. Okay, and here we have the full digital control for everything from what we were looking at before. The flux process to the drying to the preheat, everything. So right here you have your fluxer. This is the control for all that. Then you have your dryer. Then you have where the radiator is now, which is the preheat area. Then you have braiser, and then cooling and final cooling. That final cooling is where we're going to pick up our radiator at the end so that we can take it to the next step and show you what it takes to get beginning to end. Okay, now that it's coming out of the final cooling stage, luckily I don't have to wear the big silly gloves again. We could just take a look at this guy. Yeah, it's pretty cool now, so I think we're okay. And you can see the finished product. Now, one important thing to note is that right now we don't have any screw holes for the fans. So while we have a finished radiator that's all soldered together and all ready to go, or actually I should say brazed together, this basically doesn't have any mounting. So that's going to be our next step. Okay, now you see that now we have the ability to cut concentric perfect holes. As you can see in the machine here, it just straight cut them. You have everything perfectly matched up for what you would need, the 120mm fan along with the spacing. Then he cleans out the drill bits, and then basically the drill bits are already oiled, and so basically this is going to keep it from hanging up on any of the material. And so we're going to knock out a couple more small holes here, and you'll basically be ready to go. Okay, now we're on to one of the final steps. This thing's almost complete, but one very important step we need to finalize here is pressure testing. This has to tell us how well it's going to hold liquid or anything else. So we're actually going to fill it up with some air and see how it will hold that air over time in order to make sure that all of the brazing and everything took effect very well. Every radiator is hand tested this way to ensure that when you get it, it's going to hold everything to even more pressure than any standard water cooling pump can apply. Now, as you can see, green means pass. If there was any sort of leak or failure, this radiator would not pass. It would go, it'd be scrapped, it'd be gone. But a green pass means that it did not leak, it was perfect. We can install it in your chassis with ease and not have to worry about anything. Now let's go ahead and check out. We've got another really cool test we're going to do on this radiator before it heads out to be final. Okay, and one of the final steps, actually the final step for testing would be the wind tunnel, which you can see right behind me. This actually will feed air through along with running an actual liquid cooling loop through it, and it will test the efficiency of the heat transfer through the radiator core itself. And they'll use not only thermal probes, but they'll actually use an IR thermal sensor to see how the temperature is affected going through the radiator, and obviously various sizes depending upon the efficiency they're looking for. Now that all the testing is complete, basically the last step would be to send it out for coating, which takes it from this raw looking material to a finished product that's ready to go to your door. And now that we have the finished product, basically we take it back to Thermaltake headquarters office, and we have a lab where we have these large thermal chambers like the one I'm standing in the doorway of. You can see this is very large, so we can fit a lot in here. Everything from individual components all the way to large chassis. What we're doing here, as you can see, is we're actually building full loops. Now these are full, all different component loops, and we're taking them with all different fluids from regular tap water to distilled water to our coolant, and we're running them in a very long test with a water heater that keeps the loop actually at about 60 C, which is much higher than your home loop will see. Regardless of CPU temperature, you'd be way above that if your water temperature ever hit that high. So we're actually testing this well beyond real world disaster scenarios for your PC. We want to make sure these components are going to stand up well beyond that, so that when you do have it installed in your system, you don't have to worry that any minor little issue like a temperature spike ever would cause any sort of breakdown. As you can see here, I mean, these are very hot. You don't really want to touch them, but everything here is running really well. They've been running for quite a long time now, a series of weeks without really issues. And so we're going to go ahead and shut this one, let it keep running, and see if we ever run into any problems. This is part of the durability testing we do after we receive the products from our manufacturer. Now let's go ahead and take a look at the real world test station we have in the other thermal chamber. Okay, now in the other thermal chamber, once again, very large thermal chamber I'm standing in the doorway of, you can see we have a test bench, which is just like a home PC setup, but we are able to control the relative humidity and the operating temperature, the ambient around the system, so that we can best simulate a home from anywhere ranging from, let's say, 18 C all the way up to 50 C if we wanted. This one is set for 25 C, which is actually quite warm. and it keeps an idea of basically what your basic household would have in a PC and how the water cooling system would perform in various levels, so we can swap the components out to see what kind of performance, overclocking, and everything you can expect from our custom liquid cooling systems. Thank you for joining us on the manufacturer facility tour to show you exactly how the Thermaltake Pacific Series radiators are made. Now, with the choices of the special anti-corrosive coated materials and everything, you're guaranteed to have a nice long life out of your liquid cooling system with Thermaltake products. So if you'd like to join the discussion of this product or any others, feel free to join us on our social media channels or our TT community forums. You can find the links to either of those right down below in the description. Thanks for watching.